Alright, hello everyone. So this is going to be a video showing you how to work with some computer-aided drafting software called Solidworks. Might also call this a CAD program for short. We're going to use Solidworks in our class, ME 2030 Introduction to Mechanical Design, but once you know how to use this, you'll be able to easily transition to any sort of Inventor, Solid Edge, what have you. Most of the processes will be the same going forward. I'm going to go through all the basics here for folks at home. If you're just following along in class and want to catch up, you might just skip ahead to the part where you got behind. So once you've downloaded it at home or any computer on campus, you're just going to double click the SolidWorks, and depending on how quick your computer is, this can take some time to boot up. Well, it boots up. I'll tell you a little bit about it. So there's two kind of ways to create an object on a computer. One is kind of parametric modeling, one is direct modeling. So most of the ones as engineers we're going to work with are parametric modeling. So we're not going to, so I'll first describe direct modeling as basically describing all the points on a surface in space. And so you can imagine if you had your phone and you wanted to describe its shape, you could put a million spots on a surface and then use XYZ coordinates to tell where all the spots are, and then you could make a mesh of those spots and you could kind of see what your shape looked like. And you imagine that would be inefficient for making something like a block, where you actually don't need that much. You don't need a million points, you just need the base, width, and height. And so that's kind of how we work in parametric modeling. We just give it a few parameters. We're going to give it, a base, a width, and tell it the height, and it can generate the solid. And then we can easily edit it. Say we want to double the height, we just double the height. We don't need to change all the points on, let's say 5 of the surfaces in that case if we're talking about a cube. So my SolidWorks is loaded up, and this is what it typically looks like. You have some various resources over here. There's actually some pretty good tutorials. If you click on tutorials, going through these are actually super helpful. You can actually, as you click through them here, you can actually, if you can't find something, you can click on it and you'll see it even highlighted for you. So I actually really like going through these when I'm learning something new, even go to advanced techniques. But even their basic technique can be somewhat advanced, weld immense and these sorts of things. So I wouldn't be afraid to try most of these in your spare time if you're interested in getting better at SolidWorks. So I'm going to close this for now, though, and let's see here. Let's shrink this down a little bit here, just so we have some more room to work. So in the SolidWorks, you have this arrow here, and then it's going to pull up these different kind of tabs at the top, or you can just stick with the basic tabs, kind of a new part, open an existing, or a new file, open an existing file, or different options here. So right now, since we don't have anything open, we'll just have system options. But you'll see once we open a document, we'll have a document options here. So we can either do things on the whole entire system, or we can do things just on that document. So let's go to open a new part, since I assume this is our first time, so we don't have any existing parts really to open up. And you can see you're going to get 3 options. You're going to get a part option, an assembly option, and a drawing option. So a part is the thing you're going to start off with, and the reason for that is a part is good for, kind of a part file is good for creating something with no relative motion, where you wouldn't even have any relative motion. So something like let's say the head of the hammer. Let's say it could be a part. It's one solid cast piece of metal. There's going to be no relative motion. As opposed to if you wanted to make a whole bearing, you might have to use an assembly, and you'd make a part out of, maybe the inner race and out of each of the balls, and then you would take all of those different parts and you would put them all together in an assembly. So you need the parts essentially to make the assembly, and you can see that in a little picture. You have 2 parts that you put together. The drawings, you can either make a drawing of a part or of an assembly, and it's really just to communicate your part or assembly to someone who wants to check your design, or someone who wants to make your design, or someone who wants to grade your design like me. So drawings are really the way in which we communicate the parts and assemblies. And they're going to have things like you can see here. They're giving you orthographic projections, which we might have talked about. It's got a little title block on the right that they're showing you. And it might even have an isometric view, just to kind of give you a feel for what the part looks like without, the real dimensioning will be done on the orthographic projections, which you've probably covered in class at this point. So let's start off with the part, since you'll need that to start before you do anything else. And let's do the flashlight part, since those are what you'll be making in the kind of the lab component of this course. So we open this up, and the nice part is you can hover over stuff and figure out what it is. And so you can see this is the feature manager's design tree. So this kind of stores all the information about all the planes, all the different things you've done to make the part, and you can go back and edit it. And you can see even material and that sort of thing. And so there's a couple different tabs here, but for the most part, for now, we're going to be working in the feature manager design tree. So make sure you're kind of selected on this one. You're going to still see that you're going to still have your different options along the top, as well as the arrow. We'll open up even some more options, and we'll work on that occasionally, but mostly we're going to work in this ribbon. So they've kind of made SolidWorks look a lot like Word, I guess the Microsoft Office suite to be kind of more specific, and that you got this ribbon, and you have these different sets of things you can select in the ribbon, and this will give you different access to different tools and different groups of tools. So, and you'll see we're going to be mostly working in features and sketch to begin with, and then more advanced will be kind of evaluate and simulation. So, but let's start in the sketch. And so let's have you pull out your flashlight window, the drawing of it that I give you, so you can take some time there. So the first thing we're going to do when we do any sort of parametric modeling of a solid is we're going to sketch in 2 dimensions, and then we're going to find a way, 1 or even 2 dimensions, and then we're going to find a way to pull that or kind of add additional information to turn it into a 3-dimensional shape. So this window is pretty simple, so we're going to start by sketching. And you have 3 options, front, top, and right. And to start, these are pretty much all equivalent. And so it's more kind of a matter of how you define your part. Since I'm going to be drawing the looking down at my window, I'm just going to do the top plane. And you can see right now then it gives you an origin that it will snap to. So it's kind of when it shows this color, it'll snap to it. And you need to be really careful in SolidWorks as it snaps to different things, because it's what you click on. You have to be very intentional with what you click on. And if you click on something wrong, it's going to do something that you don't expect. And you're going to have that happen a lot to you at first. And so you're going to just have to go back occasionally, and you'll kind of get used to the different, clicking on exactly where you want to click and not slightly off or have it snapping somewhere you don't want. So what I'm going to do is I'm going to first create kind of the general rectangle that is my flashlight window. I typically like to start my rectangles at the origin, because that way it actually locks this point in space. So you'll see actually on this bottom left it has this little coincident point. That says that the bottom left of my square is coincident with the origin. But you'll see my top right, for example, has nothing like that. So I've already defined this point in space for it. And the reason I do that is I want my sketch to be fully defined. So right now you can see it's underdefined. And that's because I haven't told it, the location of this second point here, or the 2 side lengths and 1 point. So what you could do is we could click on our solid here, and we could give it some parameters, 3 or something like that. And that'll actually change it to the right size, but it actually won't fully define it, because what you'll see is if we dimension it, that'll give it the overriding constraints here. And so we know that our flashlight face is 0.9 inches, or 900 thousandths. And so you can see it just changed it. But now if I go and try and change it again, you're going to see, oh, it's overdefined. So that's the reason why it's good to define these with Smart Dimension. Once we do this, you're going to see that we've become fully defined and all the lines turn black. So once the line is fully defined, it turns black. And you might be wondering at this point, like, okay, is this 0.9 inches, meters, what is it? And so there's a couple ways to do this. So right down here is the unit system. We're in inch, pound, second, so we're in inches. And you could usually change to millimeters, meters, that sort of thing. Or up in here, you can see in our document properties, we're going to have units and we're going to have IPS. So inch, pound, second. So be careful to check this first, otherwise you're going to have to redo everything, which can be kind of annoying. So there's other little things that you can change about your document properties, like I said before. See, we're working in ANSI. That's kind of the North American standard. Or we can change things about, the entire system, not just a specific document. Like, okay, maybe if we want to do this, this dimension line, we want it not to be this yellow, we want it to be black. We can change that. Or what you might have to do a lot is what in this whole wizard toolbox, what you'll actually find is sometimes if you upgrade to a new edition of Solidworks, it won't update the location for the new either like whole wizard or in these file locations for like new document templates, or it's usually thread profiles will get messed up. So all of these are in the 2017. So if for some reason you go to make a thread and it doesn't show you the thread, you need to come here and you need to locate the thread profiles for the most recent version. And so it's probably going to be C program data, blah, 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 as you can see here. You'll have to change it to this. And yours might say SolidWorks 2016 thread profiles. And so the 2016 SolidWorks is having trouble reading those files. So those are the kind of the common times when you might have to use these sort of settings. But let's go back. So one helpful command is, let's say I drew this and it's way too small. You can hit just F, and you can practice that now, and it's going to fit your kind of part to the screen, which is nice in these cases. Usually you first draw something, it's not the right size, you hit F and it makes it the right size. So this is the general shape, but you can tell if you're looking at the drawing that there's also some kind of radius, some curvature here. These don't have sharp edges, and there's some holes that we need to make. So you're going to look in here, and they're going to call it a fillet, not like a filet mignon or anything like that, but a fillet is what that's called. And what you just have to do is basically tell it the two lines that you want to put a fillet between. So let's say I want a fillet between here and here, and it naturally draws it with this radius. So quick water break. That's good. So we can see in our drawing that our fillets are 0.13, well, it says 1.3, but that's because we've just rounded it off from 1/8 of an inch. So you'll notice in English units, we're always going to work in halves, quarters, 1/8, 16ths, 32nds, 64ths. We just keep folding things in half or dividing them by 2. So, and I could either click, check mark here, hit enter, but I'll just add them all in the same tab. Notice you do have to click every line twice, though, to say for each fillet you have to click it. And you can even see right after I did that last one, I could even right click on my mouse if I want to be quick, but you can just go with the enter key. And then look, I can even do more if I want, but I'm going to get out of the fillet. So now we have our right edge, and you can see there's a bunch of different little these are basically constraints on our drawing. So at this point now we can draw a circle, because that's going to be our hole, like this. And then we'll have to smart dimension 3 things about the hole. 1, its position in XY, 1, its diameter, and that's the 3 things. So you can see here, or let's go out of here and delete this. So I have to get out of smart dimension by hitting escape, and then I can delete it. One thing cool when you smart dimension, you'll notice, look how I move it around. I can do different sorts of dimensioning, which you could do in your drawings. And you'll notice some other thing is that the arrow always points to the center. So that's good practice. If you're going to say the dimension of a hole, it should always point to the center point of that hole. So in this case, we can see that this is going to be roughly 0.16. And you can see there's some tolerance. When you actually make it, you're not going to be exactly 0.16, and you can be off a little here and there. And then we're also going to make this an eighth. And you can see I kind of did that a little quickly, but you can see if I clicked here or here or here, that's three different things. And so I wanted to find the distance between this edge and the center. So I clicked on the center, and then I need to click this edge. Not this point, not here, not down here, but this line here. And then I can drag it down. And I'm going to put this inside here. Oh, and so I may have even clicked on something wrong here. So we have 0.13 from here. So I should be able to click here. So there's something up here. So even I make mistakes on the occasion. So let's go back. So I think at this, for some reason it might think that this point is coincident with this point already. So I'm going to delete this, and let's try this again. So you can see what happened probably is when I drew it, actually, I drew it with this little dashes going, and so that meant it was automatically in line with this, so it automatically gave it this distance. So you can see that's a case of, easy little mistake, wasn't paying attention. But I can do the same thing, draw it over here, 0.16, dimension the bottom like I did before, 0.125, dimension it from the left hand side, 0.125, and now everything's happy. So, we're all going to make these mistakes, so just sometimes you got to back up, figure out what you probably did, and you're going to have to ask questions at first, but once you kind of get experience with it, you'll kind of quickly identify where you went wrong. So now I could just repeat this 3 times. Could even do some things like mirror them, but I want to show you the linear sketch pattern. So what I do here is I click on linear sketch pattern. What that does is you can see here kind of in this little, symbol for it, it's actually, you take one shape and you make 4 of them. So the first thing to do, I think, is to select the entity that I want to pattern. So I want to pattern this shape. And then I want to tell it what axis. So first I'm going to go along the x-axis, and I want to space them out by, you can tell in the drawing, I have 0.9 minus 2/8. So 2/8 is a quarter, so this is going to be to 0.65. And when I click here, hopefully it'll auto move this little yellow circle showing me where it's going to be. And that looks right. And then the second one's the y-axis. But you can see the y-axis is on the page. That's not really what we want right now. We actually want something like the z-axis. And so see if I click on it if it does it. No, it's just going to turn it on us. So that's not what I want. So let's go back to where we were. So I want to tell it the z-axis. So what you're going to have to do is come in here, and I could equivalently just click on this line, for example, and that would tell it. Let's see here. Display instance count. Oh, so I need to show that I want 2 of these. There we go. So here's the second axis. So I could click up here to show it this second axis. Oh, even now too, we got a couple of things getting mirrored, so we got to be careful here. So instead of kind of trying to select this z-axis where we want, I just kind of clicked up here, and again, we're going to want to go 0.65. Boom. And they're 90 degrees, I could go 45 degrees, and do something like that, but that would be silly in this case since this is what I want. So boom. One thing you'll notice is that I'm still underdefined and they're not all black. So what we could potentially do is we could click here, I'm going to hold control, I'm going to click these 4, I'm going to tell them that I want them to be equal. So that's going to tell them that I want them to all have equal diameter. Oops. And so you could try and make them all have equal diameter, but since we feel a little silly in this case because we've already said it's mirroring this entity, so it's already kind of got it already has that. So in this little thing you can see it's showing that it's kind of patterned in space. So yeah, so at this point at this point, we've defined all of these, and we could even go into smart dimension and dimension them all too, to make them all black, but we can even go and do that. So we can even go here to here. Oh, so it's already got that dimension in this pattern feature. Alright, so it looks like we just had a little bug. All I did was click on it, and then all of a sudden it became fully defined. So yeah, so it should be fully defined at this point. We should be good. You should be good to go. If you have any errors, yeah, just kind of click on it, try and drag it around like I did, because that'll tell you it's fully defined if you can't move it at all. And it seemed like that kicked it into gear. So I'm going to exit my sketch. So you see I have this 2D sketch, and you know what we're going to make is we're going to make kind of a 2D, this 3D window with some thickness. So what we have to do now is extrude this out. So I just come to features and I hit extrude, and I'm just going to extrude it the 16th inch that we're going to be able to buy from McMaster, Granger, MSC, whatever your favorite distributor of acrylic is. Hit check, and there you can see we have our 3D part. You can change things like the material if you want. At this point, sometimes it takes a second to load the material. This one wants steel, we want some plastic, and we want some acrylic. So we can apply that, and so you can see now it's a little clear because it's clear acrylic. So now it's just good to make sure you save your document and save it as something you know. So call this flashlight window. Okay, good. So let's move on to the next part that we're going to build, and let's start with the handle. So we can all pull up the PDF of the flashlight handle. So it's kind of a round object. And then, so now that you probably have that up, we file new part. So what we're going to do is we're going to kind of build this flashlight from the bottom up. So what we're going to start with is drawing a circle and then kind of extruding it up. We could also start with like a rectangle and revolve it, and I'll show you that for one of the parts, but that wouldn't probably be the easiest way to do most of this. So again, I'm going to sketch. I'm going to start on the top plane because I'm going to kind of build up, and that's just kind of a personal preference. I'm going to do this circle, and there's different ways to define circles, but I'm just going to do the center and a point on the circumference. So again, I could click somewhere in space, but let's just define the center at the origin. That way I don't have to define it in space. I'm going to click out here. I'm still in inches, so that's good. And so I could put in here a radius of 0.5, and then click check. You'll see I'm not fully defined until I actually smart dimension it to this. You can see diameter symbol 1 inch. And I can hit F, and it'll zoom it in all the way. So I'm going to exit smart dimension, I'm going to exit my sketch, and I'm just going to extrude this up. And so you can see that it's 1 inch, and it goes up for 1 inch all the way to 2 inches minus 0.65. I personally always forget if Solidworks will let you do the math, but I guess it does. Whoops. So I'm going to hit enter, and then I can hit F again, and you can see, okay, so I got that little base. So the next thing to do is let's draw the little top part. So again, let's go back to sketch, and this time I'll sketch right on this face. And you know, if you don't like looking at an angle, there's a couple ways to do it. We could get out of the circle feature, and we could, come here and we could click on this sketch and do normal to. So we can do that. So some other useful things too is if you hold down on the roller key and move it in space, you can kind of do this, this kind of rotate the view. If you scroll the wheel, it'll go in and out. And then this, if you just kind of click, it's a selection. And so there's a lot of different hotkeys, but this is for the most part what I like to use. So yeah, for changing the views, come here and just click on the top, or come here and click on the top, whatever our preference is. So we're going to draw another circle, and this top circle is going to have a little bit that has a diameter of 0.7. So 0.35 is the radius. I'm going to exit that sketch. We're going to have to smart dimension it. Oops. Sorry, I didn't want to exit that sketch just yet. So I'm going to come back. I'm going to left click and then do edit sketch. I'm going to dimension it to define it. Looks good. And you can see I haven't had to define the point in space since everything's at the origin. So I'm going to exit the sketch again. I'm going to extrude this. I got to tell it what to extrude. And so I'm going to extrude this up. So this goes for this little part is going to go for just the 0.5 minus 0.35, so 0.15. And then we can go, oh, you know what? We actually kind of missed something. We don't have the angle between here. So I kind of wanted to show you how you could edit this feature afterwards. So we're going to come here, left click on it, left click here, and let's actually make this the 2 inches minus 0.5. So let's make it the full 1.5. So we're still, so it still makes the same size, and it makes it from here, so that's good. But actually, we need to kind of make this at an angle here. So we could do a fillet like before, and you can see it's going to kind of round it. Or let's cancel that. We can do a chamfer, which is more of that straight angle that we want. And here we're going to do this 45 degrees, and the distance that we are going to want it to go is just going to be the 0.15. And so I'm telling that because it's 0.65 minus 0.15. So now you can see it kind of smoothly goes from this edge right to this other edge. So now we have our kind of flashlight base with the angle. And next we just need a little bit of thread. So let's try doing the revolve in this case. So instead of just drawing a circle and extruding it again, what I'm going to do is I'm going to sketch, and I'm going to come here and I'm going to sketch on one of these planes like this front plane. And I'm going to look normal to this plane. What I'm going to do is I'm going to draw a rectangle. I'm going to come right up the middle here, draw this rectangle, and I'm going to draw half of the part that's going to have thread on it. So I'm going to smart dimension. So half of it, so this is a 9/16 thread, so the major diameter is 9/16. So this one's going to be 9/32. It's going to be half of that. Let's see if it still can do its math. And we know it's going to be down 0.35. Something like that. And it was nice that it moved this line and this line and not this line and this line, and that's because I had this little kind of coincident point at this midpoint. So what I can do now is I can take this and I can, instead of just extruding it, I could revolve it about its own center line. And that's also a way I can make a circle on the top. So now we got a couple more things to do. We have to kind of round this base. We can use the fillet on that. And obviously we're just going to hit this a little bit with a sander. So it's just going to have a little fillet on it. It's not even defined. It tells you in the kind of manual how to make it, just to sand it down a little bit, so that it's not a sharp edge. And then we're going to do, let's do the thread on here. So now, since we're in features, we're not going to draw a sketch and try and make it, what we're going to do is we're going to go to this whole wizard and we're going to do some thread. So I got to tell it the thread location, so I want it to start here and go down. Okay, degrees, how far I want it to go. So I don't want it to go quite that far. You can also here this optional start location if we want it to just start somewhere else. So I'm going to shrink this down to this 0.35 and see how this looks. It doesn't always, so it's still a little bit deep, but since we're going to be adding this, well, we're going to be cutting this thread away, so we probably want to make it a little bit shorter, so we're going to make it more realistic. Let's do a 3.2. So that looks like what we'd actually be able to, oh, maybe still a little bit low here. It's just a 3.1. So I have to turn to find it. So that looks like where we'd actually be able to cut the thread. So we want inch die, so we're going to be cutting it away. We start with the major diameter and we're cutting this away. And this is 9/16 and then 18 threads per inch, so that's the fine thread. And we want to cut the thread, not extrude the thread. And we want a right-hand thread, which is the normal one. So that's good, so let's try it. Boom. So this is what it looks like when we cut the thread. And so you'll find this sometimes when you cut the thread that, oh look, it kind of oddly missed a portion of it. So let's go back and edit it. So we can start with some offset, and we can do some negative offset of negative 0.25, let's say. Or we can, I guess, I didn't really like the negative, so let's try 0.1. And you can switch the directions instead of doing negative. Sometimes you gotta outsmart Solidworks sometimes. And since I moved it up 0.05, I'm just gonna add the 5 onto here. And that way it ends right where I had before. And there we go. Now this looks more like how it actually cut. It wouldn't have quite this sharp edge here, but I think we can live with that small discrepancy. So the last part is we need to make the hole that the battery is going to sit in. So it's going to have a diameter of 0.41, and it's going to go 1 and it's at 5/8 deep. Oh, I actually made one mistake. So this thread is 5/8. So we're going to have to make a special note of that actually. So this one right here is actually 5/8. It's actually not the 9/16 as specified by the drawing. So it looks like mine doesn't have it currently in its 9/16 in it. So we'd have to either download that online or kind of manually add it in. But we'll leave it for now because I'll show you later how you can kind of deal with that on the drawing just by kind of manually editing what it says. But everything else looks fine. So we're going to do this hole, and so again this time I'm going to sketch right on the top, and instead of doing kind of the extrude as we did before, I'm going to do an extrude cut. I'm going to cut it away. So I'm going to come in here and I'm going to draw this hole, which is going to be 0.41 divided by 2, and we can just smart dimension it. So it defines it, exit the sketch, extrude the cut down, the 1 and 5/8. So sometimes you'll see if it says 1.63, I'll actually put in 2.5, and that's just because I made all this flashlight stuff actually in 5/8, and just we're not going to be machining quite to that tolerance. So on the drawings I just 0.63, but so I mean either one will be fine. But I just like to make it in 5/8 just in case we did want to make it more precise. It would have the right value in there. So, and there's different, blind, we go through all. This could be the mid plane, but we just want to blind from down here. You can see it's giving us the right thing. And we can look down. Oh, there's our flat bottom battery hole, which we'll need to use a special drill bit to make. So again, you might want to be saving these along the way, especially if your computer has a, you know, a liking to crashing. So flashlight base. Okay, so now we have our base. So we got our last part to make is going to be, make sure I'm recording all this. Okay, good. Our last part to make is going to be the flashlight head. So this is the one that so this base was going to be made on the lathe. This flashlight head is going to be more made on the mill. So pull up the flashlight head drawing, and then so let's open a new part. And so we can kind of make this one in SolidWorks as we would make it in the machine shop a little bit. Instead of kind of building it up, we'll actually like kind of adding and part by part. We'll actually start with the full thing and then remove the material. So we're going to start with our 1 by 1 inch block of aluminum. So we're going to sketch, and again, I'm going to sketch on the top plane because I'm going to kind of build up, and I'm going to start with a rectangle, and I'm just going to smart dimension it to 1 inch by 1 inch. I'm going to exit the sketch, and I'm going to extrude it out the full height of this part, which is 1.5 inches. Features, extrude. I'm going to extrude it the full 1.5 inches. Okay, so this is the block you'll start off with. So you'll probably cut kind of some extruded 1 by 1 aluminum to, you know, slightly over 1.5, and then you'll machine it down on the mill to exactly 1.5. And then you'll start these various processes. So let's start with the top start with the bottom since it's a little simpler. So I'll rotate this down, and let's sketch on this bottom. And what we're going to do is first we're going to kind of cut out this recess that's 3/4 of an inch. So I'm just going to draw it anywhere. So here I'm not going to have an origin to put the center at, so I'm going to have to define the center too. So it's going to be in center of the circle is going to be in the center of the rectangle, which is 0.5 by 0.5, and it's going to have a diameter of 3/4, as we said. And you guessed it, we're going to have to extrude cut this to the 0.16. So it looks like that. And you can tell I also have a little chamfer on it, so we can at this point come in and give it this small little chamfer. You know, obviously this chamfer is way too big, so you know, we're talking, you know, maybe a 20 thousandths chamfer, you know, something little. 20 to 40, something in that range I think would be acceptable. So let's put it right in the middle, 3. So we'll have kind of a soft edge there. And then we have our next kind of smaller hole, which is actually going to have the female thread on it for the handle base. And so what we can do now, though, is cut out, you'll see there's a kind of a smaller hole where the actual light bulb base sits in. That's defined as 0.38, so we can actually cut that all the way through next. So let's sketch again on here, and be nice again if it found the center, but it's not snapping to it, so we're going to have to go 0.5. 0.5, and we'll have to dimension this thing. So it says 0.38, but that's going to be 0.375, so that's 3/8, just round it up. And this time I'm going to do the extruded cut, but I'm going to do it through all, so it's just, and no matter, even if I add more material, it's going to, you know, if I add more material before it, it's still going to cut all the way through. So now we have this hole going all the way through. And on the bottom we actually have even a slightly larger hole for the thread that we can sketch also on here. And we can actually, let's actually do this. So you actually kind of showed you how to do the thread that way, but we can actually go to this hole wizard and we can actually cut away the tapped hole right away. So we can come here to this straight tap, ANSI inch, that's what we want. We can do a bottoming tap since it's going to have a sharp edge at the bottom. You just make sure you don't do a straight pipe tap, because pipe has a tapered thread. It's not straight. The threads aren't straight. They kind of go at an angle. So we're going to go back to our, hey look, this one has 9/16 18. It's odd that one would and one wouldn't. And then, and here we're going to have to do blind, and we're going to have to make it go. So we want this thread to go all the way to 0.7, which you can kind of search on for the drawing. And since it's a bottoming hole, these are roughly going to go the same distance. And then we have different kinds. We have one that'll show it just as the kind of minor diameter of the thread. One, it'll show it doing both, and this one will just remove the thread. And we want it with thread callout, so when we do the drawing, it'll tell us what. So we told it what type of hole we want. Now we need to tell it the position. So we're going to say it's on this surface, and I'm going to say it's roughly here, and now we need to define this point in space. So we're going to also tell it that it's 0.5 from the top edge and the side edge. Then we click check, and then we click check. And you can see, oh, it's kind of cut away some and smalls, but this doesn't look like thread. So usually that's an issue in the settings. So you can either click on the gear, go to options, and then I'll have to remember exactly where this is. I thought it was in document properties. I thought it was in detailing. And let's give it shaded cosmetic thread. So that's just going to show us some thread in there. So that's kind of cool. We kind of know, okay, yeah, there's thread in there. That's what it's going to screw up into. So that looks good. So we worked on our bottom. So let's work on the top of our flashlight now. So now we need to first, we can kind of cut away the material and then do the holes, or we can do the holes and then cut away the material. Let's do the holes again just because we're kind of on a roll with this hole wizard. So you can see on the top there's a hole with note A, so it has some 6/32s that go down a ½ inch. So you can see here in the sizing, once you get below a ¼ inch, it now goes to, instead of telling you the actual major diameter, it has a number that corresponds. And then, but it still has the threads per inch, so we want the 6/32. And this time we want to go a ½ inch down, and both the threads can go, both the hole distance and the thread distance can go a ½ inch down. And we're going to scroll down here, and we still want it to actually show us the cosmetic thread. And again, we need to give it the position, this face, and roughly here. And then we're going to smart dimension it. And so we know these are going to be 0.175 from both edges, as it says in the note. Okay, and so we'll hit check. And check again. And we have our cosmetic thread right there. So you might say, okay, but we're supposed to have 4 of them. So just like we did in sketching, when we're actually in the feature, we can actually pattern the whole feature. And so because I have this selected right now, I can then hit pattern, and it knows to pattern this. And so my first direction I want to be here. My second direction I want to be here. And I want 2 in each case. And since there's 0.175 from both edges, that's 1 minus 0.35, so 0.65 from each other. Hopefully this works. I might have clicked on the wrong edge here at some point. Oh, so I got the right edges, but it's just going down instead of up. So I'm just going to have to switch the direction. Got the right hole. And let's hit check. Looks good. We got our full hole, so we only had to do 1. Saved a little time. So next, we're going to need to extrude cut down the the little recess for our window lens. So I'm just going to sketch on this front, and then I'm going to draw a rectangle. Just going to define it so we know that the rectangle is going to be, so the whole thing is 0.9, and the whole thing is 1 inch, so it's 50 thou from both sides. I know sometimes when I talk in this 50 thou language it might be kind of confusing, but we'll use it just to kind of practice the language that most designers in the US use. We talk a lot in thous, and that's just short for thousandths of an inch. And then 0.9 by 0.9, and then I just need to give it the radius, here in the corner. So I'm going to come here and give it the kind of 1/8 of an inch radius that it has in each of the corners. And you can kind of yeah, so do that one, then you have to click on this one, click on this one, click on this one. And now you'll have the right shape. We can exit the sketch, do the extrude cut, and this is supposed to go down 50 thou. And so our window will stick slightly up because it's 62 thou, which is 1/16 of an inch. So, you know, we only got a couple more parts to do. So this is the diameter of the kind of the actual metallic portion of the light bulb, but the light bulb gets bigger on the outside, so we need to cut away a little bit more. So again, we can kind of sketch just on the top face, since we have the dimension from the top face, so that'll make it easier for us. So again, we'll have to smart dimension. Or actually, I got coincident here already, so out of smart dimension, back in. There you go, so I had to hit escape. And we can see the diameter of this hole is 0.65, which is 5/8 from the top view on the top left. And then we're going to extrude cut that down the 0.58 from the top surface. So if you sketched on this surface, it might be slightly different, so remember that. So now we have that. So that's pretty much done, except for all we need is the set screw to hold the light bulb in place. So that's going to be on the side here. And again, we're just going to, in the feature, we're actually just going to make the hole here. So again, you can see the side hole is note B. It's a 1032. So we have this, and so it has a number 1032. And it's going to be up to next. It's only going to go halfway through, so it just pinches it. I'm just going to give it the position. It's on this face. Kind of choose any of the faces at this point. And then we're going to smart dimension from here up to here. 0.69. Hopefully that lies roughly in the middle. And then it's going to lie in the middle here. So 0.5. I'm going to check. And check one more time. Let's see, we have our hole coming down in. So one thing we're going to check here is, let's check why it's not quite in the center as we would kind of expect it, expecting it to be from before. So what we can do is, if I want to check something, I'll first make sure I made this position right. So just kind of edit this feature, go into the position. So that looks right. 0.69 and a half. That's that looks like the right call out there. And then we can look at how deep did we make this cut. And it looks 0.58 from the top. That looks right. And the last thing we're going to check is our 9/16 18th hole. And let's see here. We're going to edit this feature. We're going to go to position. Okay, position looks right. And it's 0.7 down. which is right here. So the only issue is that it's actually slightly less for the portion that's threaded, and the last bit is just that little angled portion that you can see when we do here. So the last bit is a little angled portion. So now it's going to be roughly 0.7, and you can see it's roughly in the middle. So that's the flashlight head right there. If you wanted to confirm that this, this line here is indeed 0.7, and then you wanted to tweak it a little bit, you could either figure out all the dimensions, or we could come to this evaluate and measure, and we could kind of just measure from, zoom in there, get this line to, this face, and you can see it's this green dy is 0.69, so it's slightly under the 0.7, but so again, we could kind of edit our 9/16 temp tool, and we can make this, let's try 6.6. Okay, and we can measure again, and we'll measure all the way from here to this face, and you can see we got the dy of 0.7. And we have now the whole, when we kind of zoom in, looks equal spacing here and here. So don't ever forget to save your part. So save it in a place where you can find it. Make sure when you're saving these too that you're taking them home with you. Save them on a flash drive, because you can't guarantee that when you save them on the computers at school here, they're not going to be erased next time. So you want to make sure you save them. I can't tell you the number of times I've had someone come to me and say, "Oh, I can't turn it in because I did them all, but then I didn't save them." So you don't want to find yourself in that position. So we got flashlight head here is what I've been calling this. Okay, so that's basically it for the tutorial on how to make the 3 basic flashlight parts, and the basics of working with Solidworks, and you should be familiar with kind of a lot of the sketch features now. And I think if you've worked with PowerPoint a little bit, you'll be able to easily figure out how to do some more sketches, different shapes and that sort of thing. And basically talked a lot about extruded and revolving, extrude cut. You kind of figure out how the revolve cut would be like, kind of revolving. Instead of revolving material, you're revolving to cut away. The only thing we didn't really show you was this swept boss base, which is basically extruding instead of in a straight line along a path that you tell it. Or the case where like lofted, where instead of giving it 1 sketch, you give it 2 sketch, and you go along some sort of path that you also define, and it smoothly goes from one to another. But to learn those, we're actually going to have you come into here, help, SolidWorks tutorials, like I showed you before, and go to these basic techniques and do the fillet, the revolve, sweeps, pattern, and lofts, and then you'll basically know all of these. And if you want, you can even start to mess with surfaces and sheet metal. Really just kind of build your repertoire for SolidWorks skills. Alright, so I'm going to conclude with that, close down SolidWorks, and stop the video. Alright, good luck.